Okay, I wanted to give you folks a chance to try one of these problems similar to what we did in the last video, where we're looking at a composition of a trig and an inverse trig function, but instead of having a number here where the trig ratio would go, we've got a variable expression. So here I'm looking at arc cosine of root u. Now, I told you here that u is bigger than 0. I know u isn't negative just by virtue of the fact that it's underneath that square root sign. And I know that the square root can never spit out anything negative. So really all this is telling you is that u is not 0. U is some positive number as opposed to 0. This expression tells me that u couldn't be negative anyway. Okay, so I would like you to pause the video, see if you can work this out, then tune back in and we'll work through it together. Welcome back. So I'm going to call this thing theta. And then what I know is that cosine of theta is root u, and theta is in the interval from 0 to pi. Now that corresponds to either quadrant 1 or quadrant 2, but because root u is positive, I'm in quadrant 1. And that's nice. That means I'm not worrying about a reference angle. I know that theta is just an acute angle in quadrant 1. And then since cosine of theta is root u, I'm just going to write that as a fraction. That's the important trick to remember, that I can just write that as root u over 1. And then that makes the adjacent side root u and the hypotenuse 1. So now I can solve for the opposite. So root u squared plus p squared is going to equal 1. U plus p squared is equal to 1. I'm trying to solve for p, so p squared is 1 minus u. P is going to be the positive square root of 1 minus u. Okay. Now, I also know that 1 minus u would have to be a positive number, or at least a non-negative number, in order for me to be able to take the square root. But this wouldn't make any sense if this was negative, because in order for this quantity to be negative, u would have to be bigger than 1. If u is bigger than 1, the square root of u is bigger than 1, that's not a number that I can plug in. So it's always understood when you're given an expression like this, that that expression is in the domain of arc cosine. And the domain of arc cosine would be numbers between -1 and 1. Those are the trig ratios that cosine can take on. Okay, so I've got, let's see, we'll label this side p as root 1 minus u. And then we were trying to evaluate tangent of theta. I'm in quadrant 1, so it's positive. It's going to be opposite over adjacent. So it's root 1 minus u over root u. Or if I prefer, I could write that as root 1 minus u over u. Now, if you look at this, this seems like it's breaking the rules for radicals, because I've either got a fraction under a radical or I've got a radical in the denominator. It's true that we would not leave numbers in that form. However, when there are variables, it is okay to have radicals in the denominator like this, or a fraction like that. With numbers, we will always rationalize and simplify. With variables, it would be okay to leave your answer in this form.